Hello everyone. So this time we want to talk about extrema of a function. Then we need to know what this means. What does extrema represent? Okay, so this means basically the maximum point and minimum point of a function. Okay, so for example, whenever we draw any curve here, then you see that this point, there will be our minimum point, and then the other way, if we draw this way, then this point will become our maximum point. So just call those points we are calling as a extrema. Okay, then let's just look at how the textbook define the extrema of a function. Definition of extrema: let f be defined on an interval I containing c. 1. If c is the minimum of f on I, if fc is less than or equal to fx for all x in I. Number 2, fc is the maximum of f on I, if fc is greater than or equal to fx for all x in I. Okay, so this definition sounds very complicated, but if we do the graph and then just look at what this kind of definition means, then it makes more sense to you. Okay, so I'm gonna just draw another random graph again. So I'm gonna just make something like this. Okay, then I'm gonna just define the interval maybe here. Okay, so this is our given interval. Make sense? Okay. Then now, so you know that maximum is located on right here. So I'm gonna just define this C, then F, C represent our maximum. Okay. Then now, let's look at other fx value. You know, from here, so all these points, there's so many points on the interval I, all these points, they are representing fx here. So whatever you choose, so for example, this is the maybe fx1, this one, fx2, and fx3, wherever, fx4 like that, you know, all those values are smaller than fc. It's obvious because they're below fc. That's why, you know, it makes sense here. So if maximum first. So fc is bigger than or equal to fc, then this becomes maximum here. Okay, the same thing, I'm gonna make another interval. So like this. So this time I'm gonna make this interval here. Okay. Then you know that this is the minimum, right? So I'm gonna just say this is also maybe t. Then you know f t equal to our minimum value. So on the definition here, if it is minimum, then this ft is always smaller than or equal to other fx value, right? So similarly, I'm gonna just put it any fx value here. So here, maybe fx1, you know, so it's fx2, fx3, all those values, they are above this FD value, right? Therefore, this concept makes sense basically. If it is minimum, then FC must be less than or equal to fx basically. Okay? Then let's start looking at some example. So let's look at this graph. Then can you find out extrema of this function? So based on what we have discussed, so I can just guess extrema located here and here and here. So those points, so this and this is point, those 2 points, now we can say minimum, and that can be maximum so far, right? But please look carefully here. What if I determine the interval maybe this much? Okay, then do you think this point is going to be minimum value? I don't think so, because that's much lower point, so I can say that's the minimum value. What about this point? We cannot say maximum either, because some point, some fx value, they are much higher. Those values much higher than this value, so we cannot say that's the maximum. However, because they're turning point of this curve, so they have meaning here. So all these points we just call the relative extrema. Of course, those value cannot be absolute minimum or absolute maximum. Absolute means it must be maximum, it must be minimum, but these 2 points, even though they are not absolute maximum and minimum, but that's the turning point, so those values we always call the relative extrema. So now this point can be the relative maximum, this one becomes the relative minimum basically. Now I can say, so I'm going to delete this arrow sign here, and this point can be, in this case, absolute minimum, because in this curve, this any other value the lower than the particular minimum value, so I can define absolute minimum. Okay, so the value of the derivative at the relative extrema. Okay, then how to determine where the relative minimum or maximums are located? Okay, so if any graph is given, that's easier to define that. But what if not? So look at this example. So the given function fx equal to 9 times x cubed minus 3 over x cubed. So whenever we have this kind of a function, then we can find the relative extrema value as doing derivative here. Okay, so I'm gonna let you know how to find the first, and then we actually solve this problem. So whenever we have fx value, and then you make derivative here, just find out the derivative equal to 0. Then you can find some particular x value there, right? So that will be your extreme value here. Okay, so now let's solve this problem. So this one forming as fraction, but somehow maybe I can just using simple power rule too. So even though I can use quotient rule, so I'm gonna just distribute this one, then fx equal to 9x squared minus 27 over x cubed, and then using the heart rule and divide them, then I can using simple derivative rule instead. So fx becomes 9 over x minus 27 over x cubed. Okay, which means I can rewrite fx equal to 9x negative 1 minus 27x negative 3. Okay, now I'm gonna find the derivative of this function. So f prime x becomes negative 9x minus 2 plus 81x negative 4, which means we can rewrite that negative 9 over x squared plus 81 over x4. As you see, x4 is common denominator, so I can rewrite a prime function equal to negative 9x squared plus 81 over x4. So here, from the beginning, actually, we have some limited value. X cannot be 0. In this case, this value will be dismissed because we have already x cannot be 0. So I'm gonna using only this one. So negative 9x squared plus 81 equal to 0. Then factor in negative 9, then x squared minus 9. Therefore, x squared minus 9 equal to 0, x equal to plus and minus 3 here. Okay? So now we can find out maybe external value located on x equal to 3 and negative 3 basically. So we will develop how to find where, which point will generate the relative maximum and minimum later. But so far, that's how we can find critical value. And that critical value basically generate either the relative maximum or minimum. And then we will continue more problem for next video. Thank you.